Hi, in this video, we're going to take a look at the steps that we go through when we're doing supervised learning. Okay, so in supervised learning, what we're doing is that there is one variable that we want to either understand better or predict or control or something similar to that. And what we're going to do, we're going to build a model where we have independent variables, also called predictor variables, that we believe have a relationship with that target variable, that dependent variable. And so typically, most often, we're trying to predict the future. But as a statistician, as a data scientist, maybe I'm going to try to understand the relationship between the variables better, maybe to understand the situation as a whole from a more of a statistics point of view, or possibly I could be in the control situation where maybe I have like an assembly line and I have a variable that I would like to have more control over. How can I control this? How will things change if I adjust the variables I have influence over? All right, so what we're going to do, we're going to just talk about just the general steps, high level. I'm not going to dig into anything too deep. It's just going to be a pretty quick view. Now, I'm going to talk about a whole bunch of steps to go through, and now something I want to say is that these steps, if you talk to another data scientist, another statistician, another machine learning engineer, they will probably have a different list. And it might be longer, might be shorter, they have it in different orders. Honestly, it depends on your project, it depends on your stakeholders, depends on your boss, what the right order is or what the steps are. So whoever your boss is, listen to them and do what it takes to get through your project. Our number one goal is to make our stakeholders and our boss happy. So don't take this as gospel. This is more of just to give you an idea of what it generally looks like when I go through and fit a supervised learning model. All right, so here, the order here does not necessarily occur in this order. Things might, be different. And also something that's very important about this is as I work through my progress, what ends up happening is I discover something that I didn't know about during a previous step. And so I'll have to go back and modify what I did, then progress forward. And so I'm constantly moving backwards in the flow of my project until I reach my final step. And so this is, it's really not correct to put this in a straight line. It's more correct to think of this as just this is the partial ordering, and we can bounce around freely. But in general, this is a good game plan. All right, so the first one is going to be discuss the project with our stakeholders. So that might be your boss, that might be your client, that might be the head honcho of your organization who wants you to do a particular project. So you're going to identify the objectives and the scope of the project. And you're going to align the goals with the business objectives and understand what success looks like. All right, then I'm going to identify potential predictor variables. And so in the first step, you usually have a pretty good idea of what your target variable is, but now I have to go find my predictor variables. Sometimes this is very obvious. So kind of like if I receive a spreadsheet and that spreadsheet contains all of my variables, period, great. Now, if I'm in a situation, I have to go and find data. I got data in this table here, data in this database over here, table, the table has information in this schema over here, and I need to pull them all together. First thing I'm going to do is just like identify like potentially what do I want. If you're in a very large organization, this can be a huge project right here. Today for work, I was on a call, and the data engineer can't find some of the predictor variables that we feel like we want, and so we just said, hey, skip it. It's okay. Don't worry about it. If you find it later, great. But we're moving on because we need to get through this project. And so we're going to talk to our stakeholders and our subject matter experts to identify predictor variables that are very useful. Now, my experience with subject matter experts and stakeholders is that they tend to think that their predictor variables are going to be stronger than they really are. And they'll also like miss a few things. So I'm going to go through my exploratory data analysis and evaluate what the value is of each of these as I work through this. Also, I need to address variable leakage. Variable leakage is where I use a variable that is not present at the time of prediction. All right, so let's say that I'm trying to predict, a numeric value. Let's just say how we're going to predict the cost of a house. And in my data set, I found a binary indicator that effectively was above median household income, or above median sale price for the area, below median for the area. And that variable would be a very powerful variable for making a prediction, as long as I consider the area. And so if I could have that magically, that would be great. But unfortunately, that is a variable that comes into creation when the result is created, and therefore I can't use it. It wouldn't make sense to use that as a predictor variable. And so that's a huge problem that can come up. And I've had the experience where I thought I knew what was going on. I'm working through my project, and boom, I'm using a variable that's actually the output of the process I'm trying to predict. Go back, remove it, fix my code, go back through the project. All right, so now I need to go through and create a data collection plan. And so here, this will be, where are the variables? Which tables are available? Have them? Can I get them? Can we get third-party data? Could I use government data for my project? And also, like if I'm actually doing like experimental designs, how are we going to actually run the experiments? What variables are going to be included in the experiments and controlled, stuff like this. So experimental design is super important if we have the opportunity to use it. Now we're going to actually go through and collect our data and store it. And so what we would prefer to do is store it in like a formal table. Sometimes we'll end up storing it in CSVs. We want to avoid floating spreadsheets if we can. So our data collection, sometimes we'll be using databases, flat files such as Excel files, CSV files, and cloud storage. Then we're going to do our data extraction. So now I'm going to get into like more of what you think of when you say supervised learning. This is where it kicks off. Now, what we're going to do, I'm going to, depending on my situation, depending on my data sources, I'm going to get my data into my system. I'm going to prepare my data, and I'm going to start modeling. So here I just came up with an example that I'm going to take the CSV file that I have. Here, this is the mushrooms data set from Kaggle. And so here I can see just the head of the data. You can just, and notice that a lot of columns are being skipped over. All right, and now I'm going to go through and just do exploratory data analysis, understand my data better. And so something that is important to notice is just go through like, hey, this is very, small amount proportionately. Is this going to be really that useful? If I have numeric data, I'll look at the mean, median, mode, skewness, things like that. For categorical data, I'm interested in getting in like sparse levels, or I want to know the percentage and count of all the different categories. Here, I'm just running through like a quick example because this isn't the point of the video. So, let's go through, do our exploratory data analysis. Now, something that comes up here, you'll notice that veil type is a constant. And because of that, it's a useless column. If I would have gone through and tried to include this in my model, it could have thrown off problems. There's no point in having this in my data set. So I'll need to make sure I remember to remove this column from my predictor variables. So we just get through, got all these different ones. All right, so now I'm going to do my data filtering. So in the process, typically identify rows of data that I should not include. And so part of that will be maybe there's too many missing values. Maybe I don't trust the observation. Maybe I think there's some mistakes in it. Maybe it's not relevant to my data. So for example, I might be working on like insurance data, let's say commercial insurance, and my project is on small commercial, let's say small and medium commercial, and some data for large commercial was in there. Well, I want to remove the large commercial data from there. I'll filter those out. So there I'm filtering out the rows of the data. Also, I want to filter out columns that are useless. So if I have a column that has too many missing values to be trustworthy, or I have a column that's like constant, maybe we know that there's a better version of the column somewhere. I need to filter out some stuff. Now I need to go through and do my feature selection. We'll talk about feature selection more down the road. And so here I just went through and I selected basically everything just to run through the video. But in a real life project, I would go through and consider all of these. And I personally like to do is kind of like have a list going from best to worst of this. Here, this is just the order that it's in the data frame, but I would use like Cramer's V or maybe chi-squared test statistic or maybe R-squared t-test, something like that, to decide, just as to get an idea, just a rough order of which columns look like they're most useful and which ones are the least useful as an initial look at my columns. Now I'm going to go through, I'm going to impute missing values. Something that's very nice in Pandas is I have the fill in a function. And I just do fill in a, boom, I've got it. Now I like for categorical data to make missing its own level. I find that this is a very good thing to do. That way I'm not making up any fake data. If you have an indication, if you have a level for missing values, I recommend n/a like I have it here, because that's what Excel will do. And your stakeholders more than likely are working with Excel. And because of that, you want to do things that's more comfortable to them. So I'll be using n/a for missing values of categorical data. All right, so let's do some feature engineering. So feature engineering for, I'm going to be doing things like Box-Cox transformation, Yo-Johnson transformation, binning, maybe categorical smoothing. I could, do interval binning on a numeric. I could do quantile binning on a numeric, possibly, depending on the situation I'm dealing with. If I have like zero inflated data, I might choose for a numeric value. I might choose just to do 0 or 1 for if it's 0 for 0 and 1 for anything that's not 0. It depends on what's going on. Now here, I'm just going to go ahead and I'm going to do binary binning. So the most important data prep step for your categorical data is binning. Think about states. If I have 50 plus states, so when I say 50 plus, that includes Puerto Rico, includes American Samoa, Guam, Washington, D.C., the Mariana Islands, Virgin Islands. I've got over 50 levels. I could possibly, like at work, I've got Canada in there. I've got also have like the Mexican states also. And so I've got like a whole bunch to deal with. And if I was to go and do dummy variable or one hot encoding of that, I'm gonna have a lot of columns. Well, what's gonna happen? First and foremost, the more columns I have, the more prone to overfitting I am. Second, sparse columns that have very little non-zero values are going to end up being like not useful. And so it's a lot of times, if I was just to take all of the sparse columns and put them into one bin, a lot of times I'll actually get a better predictor variable than if I had them all spread out. And so this will, improve things for us. It'll improve computation time, and it'll set it up so that I'll be less prone to overfitting. I'll more, if I do things well, I'll actually have better predictor variables. And so here I'm doing very coarse, just so I could run through this real fast. I'm doing binary binning. I'm saying, hey, if the average for the level of my target, if the average of my target variable is greater for the level, it's a 1. If it's less than average, the overall average, it's 0. And so here we know that whatever original value here, so let's say capped surface right here, capped surface, the very first value was an X. And you see X. So we've got a bunch of X's there. And you can see that the X levels, the average was above the overall average because of how I did this. If the conditional average of my target variable by the categorical value is greater than the overall average, then I have a 1, otherwise I have a 0. And this is a very quick, fast, easy way to convert categorical data to dummy variables without having to worry about overfitting. Now, this is very coarse, but this is fast. And I find that this is a good approach for my initial screening of categorical variables. I'll end up getting like a really good predictor variables off of this because of odor. Odor is like basically the only thing you need. And that's not 100% true, but nearly. All right, so now I'm going to partition my data so that I have a training data, validation data, and test data. All right, so this is a little bit different than how most people approach supervised learning. Most of the time you'll hear train test, that's it. Okay, we want train, validation, and test if I'm going to be building a lot of models. All right, if I'm only going to build a few models, I can do train test and I'll be okay. The reason why I need a validation set is to make sure that I'm fine tuning better and also for final model selection. Now, for training, I build my model on the training set. I check and fine tune my models on the validations data set, and then I select which model I'm going to actually move forward with. And then I run with the test set to double check to make sure I have an honest estimate of how things will perform in the future. And so validate the train set is build the model on the training data. Validation is I select what model I'm going to use. And then test set, I get an honest estimate of how my model will perform in the future. In general, you will notice that the training statistics will generally be better than the validation statistics, which will generally be better than the test statistics, which will generally be better than the score statistics of your actual, like real life predictions that you have to do. All three of these are going to, in my work, are optimistic. Expect for there to be decline in performance when you go from building your model to production. If you get to your test set and your model isn't good enough, anticipate that's going to be worse down the road. You need to do something about it. The most important thing is to go get better data if you can. After that, data prep. All right, now let's go ahead and train the initial model. So just to keep it simple, keep it light, I'm just going to do one logistic regression model. All right, so I'm going to go through. For this video, I'm leaving everything on default settings. So I've got a logistic regression model. I'm going to fit it using my training data. Here I've got the list of predictors. Here I've got the target variable. Now I'm going to go ahead and evaluate model performance. So I'm going to predict the class for each row, and I'm going to get the modeled probability of poisonous for each one. So a 1 means it's poisonous, 0 means it's edible, and the predict value is going to be 0, 1, and the predict proba are going to be the modeled probability of being poisonous. All right, so now let's go ahead and validate our model. Okay, so I have training statistics, validation statistics, and test statistics. My training accuracy is going to be the accuracy on the training data. In general, expect your training statistic to be optimistic. Now, my validation statistic, here, this is unseen data. This is data that was not used when I built the model. So this will be hopefully a good estimate of how the model will perform in the future. All right, so here I've got my training accuracy. Here I've got my validation accuracy. Now, it's normal for my training statistic to be better than my validation statistic. Here, they're both over 99% accurate. So, that's, I want to check both, because if I see that training and validation are very different from each other, if training is really big and validation is very small, then, or test is very small, that's an indication that I have overfitting. And so here I'm using the validation statistic. If I had like tons and tons of models that I built, I would use the validation statistic to choose which models I will consider for the next round of work. If I see that training statistic and validation statistics are very far, then I'm worried about overfitting. Now here, I've selected my model, pretend I have tons and tons of model, and I said, hey, logistic regression looks like the best. Now I'm going to test it to see it, how will this perform in the future? I want an honest estimate of future performance. So I'm using, once again, unseen data. So in this process, I use for this particular code, I use 1/3 of my data to train the model, 2/3 to evaluate its performance as unseen data. All right, so now I've got a better idea of what's going on. I feel like the model I selected is worthy of putting into production. But before I do that, I'm going to dig in a little bit deeper. I'm going to try to look at cases where things were horribly off, like if I had a high predicted value and it ended up being edible. If I had a low predicted value and it ended up being poisonous, I'm going to look at individual cases and evaluate, hey, what's going on with my model? Is this okay? Is this sufficient? I'm also going to look at other metrics like precision recall, root mean squared error, MAE. I'm going to look at a bunch of different ways to look at the performance of my model to make sure I understand what's going on better. All right. So here, for example, I'm going to go through, I'm going to plot my ROC curve. So this is receiver operating characteristic. And so this is a measurement of how well I can adjust the cutoffs for declaring if a mushroom is poisonous using my model. So the idea here for this model is that I walk up, I see a mushroom on the ground, and I want to use this model to get a estimated probability that this mushroom is poisonous. And now, maybe I want to go with 0.5 as a cutoff. If it's above 0.5, I'm going to say it's poisonous. Maybe I'm really reckless, I'll go 0.8. Then, if I see a probability of poisonous above 0.8, then I say it's poison. If it's below 0.8, I say that it's not poisonous. So that, from a poison point of view, this is more risky than the 50-50 criteria. I could also say, you know what, I'm very cautious. I only want to take mushrooms that have a predicted probability of poisonous being less than 0.2. So I can change the cutoff for saying poisonous, not poisonous, for any values from 0 to 1. And this curve here indicates how well my model is performing. This is near perfect. It's not perfect because the accuracy was not perfect, but we know it's like really, really close. So here's my training data, my test, my validation data, and then my test data. All right, now at this point, I'm going to review the model with like my internal team to make sure that we're going to try and poke holes in it before we release this out to the larger organization. So I'll try to show it to my close internal office, then my bigger office, and then maybe like my big boss, and then we'll actually show it to the stakeholders outside. And then we'll present to the stakeholders. We'll explain it, ask any questions, make sure that this achieves the goals that they had. I'll put, where I work, the next step is to put a model into a pilot phase. And here what we're doing, let's say we have two models actually going. We have an old model that needs to be replaced, and we have my new model that I'm building right now. We'll run both of them. And we want to see that the new model is outperforming the old model before we actually launch it into production, that we want a real life like use case. And if things are looking good, you know what? After a quarter or so, we'll go ahead and make a transition. Then we'll actually launch our model into production. And then we'll monitor performance and we'll monitor things with our input data. So one thing that is going to happen over time, the distribution of your input data is going to change. You're going to see new levels on there. So imagine that my original data set did not have Puerto Rico in it. Then all of a sudden I have Puerto Rico in my data set. I have to make sure my model will run. So I'll be monitoring my my target variable. Or I'll be monitoring my independent variables and my dependent variable. I'll lose levels. Maybe we might have an increase or decrease in missing values, or maybe the distribution of our numeric data will change. And so with that, I need to know this time after time as things progress. Now we're going to maintain the model. So this might be, I have to go through, re-pull the data, rerun everything to make sure that it's as up to date and fresh as possible. All right, so for your homework, I want you to go out, find a data set that interests you, and you're going to need two data sets. One that has a numeric target variable, one that has a categorical target variable, and you're getting these so that you can go through and use this data on future assignments. I want you to find a data set that is interesting to you. If you're interested in your data, you'll be more eager to do your homework. You'll be more eager to work on your projects. And as such, you're going to learn more because it's interesting. You'll want to go the extra mile. So what I'm trying to do, I'm trying to make it so that you want to do this because it's interesting. It's fun. You can, geek out on your data using the material in the class, and you're like doubling up. You're geeking out and you're getting a good grade. Like, it's a win-win. All right, well, that's all I've got for you. Life is short. Do math.